Morning everyone and welcome to my YouTube channel. So this problem in physics, which is kinematics under NS, this is the problem where many have challenges in solving. So this problem is actually very easy in terms of as long as you understand it, you are able to answer it. So it says that a motorist traveling 31 meters per second passes a stationary police officer 2.5 seconds after the motorist passes. The police officer starts to move in pursuit of the speeding motorist. The motorcycle has a constant acceleration of 3.6 meters per second. Then we are told how fast will the police officer be traveling when he overtakes the car. Number 2, draw curves of x versus t for both motorcycle and the car. Take t is equal to 0 at the moment the car passes the stationary police officer. Then the second part says, suppose that for reasons of safety, the police officer does not exceed a maximum speed of 45 meters per second. How long will it take him to overtake the car, and how far will he have traveled? So now, when you're answering this question, what you need to know is this. Firstly, let's imagine this scenario. We all want to reach a certain destination at 12:30 hours. Now, for both of us, we are starting, let's say someone, under normal circumstances, it takes 30 minutes. Let's say the first person A takes about, let's say they start off at 12 hours. That means to say for them to move, they take, let's say, the 30 minutes like that. Now, this is the 30 minutes that they have taken to move from that point to that point. Now, let's say for the other person, they actually take, they start off at 12:10, but both of them wants to reach exactly at 12:30. So now, this person, that means to say from this time to 12:30, this person will have to travel for just 20 minutes. So now, as you can see, we have a difference of 10 minutes. This one starts at 12 hours, this one starts at 12:10. So that means to say, for this other person, person A starts moves for 30 minutes, person B moves for 20 minutes. So now, person B, in order for him to more like catch person A, you have to subtract 10 minutes from the total time that they have taken. So in the actual sense, the time taken for person B is equal to, you are going to have a 30 minutes. You subtract with the delay of 10 minutes like that. So that means to say this other person has to be walking faster. So it means to say they will have to walk 20 minutes like that. So let's have a visual analogy. So let's say we have A and B like that. So B, they start off 10 minutes ahead. It means to say they will move a certain distance for 10 minutes like that. Then person A now starts to move. It does not mean that person B stops moving. That is where the misconception is. So this is what's going to happen. So we have a person A starts to move and B is also moving, but A is moving faster. Now, in the actual sense, this means to say the only reason why these people have reached at the same time is that this person A has moved for 30 minutes, but person B has moved for only 20 minutes like that. So we are going to apply this to the same principle with this problem. Let's answer now. So now, firstly, we are looking at how fast is or are they traveling? How fast is the police officer traveling when he overtakes the car? But for us to answer this, we need to know how much time it will take for the police officer to overtake the car. So what we need to know is that we know one thing to say: when the police officer overtakes the motorist, they have to be at the same position, meaning to say the displacement has to be the same at that instant. So therefore, we are going to use the formula that has got displacement. So we have v squared is equal to u squared plus 2as. We don't know the v, we don't know the s, so we are not going to use this formula. We have our s is equal to u t plus half at squared. So let's stick to this since we know most of the things. We know the displacement, which we can equate later. We want the time, the u we have, and everything. So let's begin with the equation for the police officer. So the police officer, the s of the police should be equal to, we are going to say u for the police times time, then we have plus our half a t squared, like that. So the S of the police, remember the police is starting at rest, meaning to say the initial velocity is equal to 0. We have times time, then we have plus our half. Our acceleration is 3.6, like that. Then we have our time. Our time is equivalent to, we have. Now this police officer, according to what we have been told, a motorist traveling 31 meters per second passes a stationary police officer 2.5 seconds after the motorist passes the police officer, starts to move and accelerates in pursuit of the speeding motorist, like that. So therefore, we are going to say the police officer started off after 2.5 seconds, meaning to say we have to subtract this time delay, like how I explained that one. So where t is, we are going to say the time minus our 2.5, which is our time delay. We square this. Then we are going to have our sp should be equal to 0 by t is 0. We can forget about that. So we have our half. Let's multiply half by 3.6. This will give us 1.8 times our time minus 2.5, like that. Then we have our squared, like that. So the S of the police should be equal to 1.8. So we can expand this. So this is the same as having this two brackets, since it's squared, minus 2.5, like that. So what we are going to get is 1.8. Then this first value multiplies everything. So we are going to have a t multiplies our second equation, which is our t minus 2.5. Then this value also multiplies everything. So we have minus 2.5. Then it multiplies everything. We have our t minus 2.5, like that. So we are going to get a value equivalent to 1.8. T by t, it will give us t squared. T by 2.5, it will give us negative 2.5t. Then we have negative 2.5 by t, it will give us negative 2.5t. Negative 2.5 by 2.5, this will give us a value of 6.25, like that. Then we are going to get a 1.8 by, we have a t squared, negative 2.5 by negative 2.5, we are going to have negative 5t. Then we have plus our 6.25, like that. So this will give us a value of 1.8t. We multiply this and this, we are going to get 5 by 1.8. This will give us a value of a 9. So we have minus 9t, like that. 1.8 by this value, 1.8 by 6.25 will give us a value of 11.25. So we have plus 11.25. So this is the equation of the police. So this could be our equation number 1. Then from there, let's account for the displacement covered by the motorist should be equal to ut plus our half at squared. Now, like that, sc should be equal to our initial velocity. We are told that this person is moving with 31 meters per second. So they are traveling with 31 meters per second. Therefore, we are going to say, so a motorist traveling at 31 meters per second passes a stationary police officer. So if we haven't been told anything like if it is we are going to assume that this velocity is constant. So we are going to say our 31 t like that, plus if the velocity, or rather if the speed is constant, our acceleration is 0, then we have t squared. So the formula will just be 31t like that. Now remember, at the point where the police officer overtakes the stationary, or at which the police overtakes the motorist. So motorist, we can add m. So the motorist, their displacements, which is the position, which is our s, is the same. Therefore, we can equate to say the s of the police should be equal to the s of the motorist. So this one will be equal to, so for the police, we are going to put where SP is, we are going to put the equation of the police, which is our 1.8 t, is it t squared? So we have 1.8 by t squared. This will give us 1.8 t squared. And then we have minus our 9t like that. Then we have our plus 11.25 should be equal to, for the motorist, we are going to have a 31t like that. Take the 31 this side, it will be 1.8 t squared minus 9t minus our 31t. Then we have plus our 11.25 should be equal to a 0 like that. So we have 1.8 t squared, negative 9 minus 31. This will give us negative our 40 t like that. Then we have plus our 11.25 should be equal to a 0 like that. Let's use the quadratic formula. So our t should be equal to, we have a negative b plus or minus the square root of our b squared minus our 4ac. Then we have over our 2a. So our t should be equal to negative, our b is equal to negative 40. Then we have plus or minus the square root of our b squared, which is our negative 40 squared minus our 4, our a. So our a value is equal to, we have, so this is our a, this is our b, this is our c. So our a value is equal to 1.8 like that. Then we have our c value is equivalent to 11.25 like that. Then we have over our 2, our a value is equivalent to 1.8 like that. Then let's do the math. So our t is equal to negative by negative, it will be positive 40 like that, plus or minus the square root of our 40 squared. This will give us a value of 1,600 like that. Then we have minus, so our 4 times 1.8 times our 11.25. This will give us a value of 81 like that. Then we divide this over our 2 by 1.8. We are going to have a 3.6 like that. So we are going to have our time should be equal to, we have our 40 plus or minus the square root of, we are going to have 1,600 minus our 81. This will give us a value of 1,519. Then we divide this value over a 3.6 like that. So our time should be equal to, we have a 40, then we have 40 plus or minus the square root of 1019 is equivalent to, we have a 38.9744. Then we divide this value over our 3.6. So we are going to have our t should be equal to, we have a either 40 plus our 38.9744 over our 3.6, or we are going to have our time should be equal to 40 minus our 38.9744. So to get our final answer, we are going to get a, so we are going to get a value of, so when we add 40 plus 38.974, it's going to give us a 78.974. Then we divide this over our 3.6. Then here we are going to get a, so if we subtract 40 minus 38.9744. This will give us a value of a 1.0256. Then we divide by 3.6. So the time it will take is equal to, so 78.9744 divided by 3.6. This will give us a value that is equivalent to 21.94 seconds. Then here we are going to get t is equal to 1.0256. We divide by 2 by 3.6. This will give us a value of a 0.285 seconds, like that. So this is what we have for our times, but we are going to discard the 0.285 because the police did not start off until it was 0.5, until it was 2.5 seconds. It did not start off. So therefore, whatever is less than 2.5, it means to say the police did not start off, and therefore it is going to be ignored. So now this time is the time, so remember, according to our equation is given as direct as, for the motorist, this is the t is using. So that means to say, for the motorist, for him, it traveled the number of minutes, it was 21.94 seconds. That means to say the police officer has to travel less time. So this is why the equation is our t minus 2.5. So for the police officer, he traveled t minus, so the time it took, it was a 21.94 minus the time delay. So the police officer had to travel this time. So our 21.94 minus our 2.5. So the police officer traveled for 19.44, which is the explanation that I was given. He has to travel less time in comparison to the other person. So therefore, we are going to use this time. So we are going to say time traveled by the police. So time traveled by police, it will be equal to, we are going to say the police, it shall be equal to t minus a 2.5, which is our time delay. So it will be a 21.944, or 4 seconds minus 2.5 seconds. This will give us a value of a, so 21.94 minus a 2.5. This will give us a value equivalent to 19.44 seconds. So this is the time the police took. So if we know the time, we can now calculate the speed according to what we have been asked. So we have, how fast will the police officer be traveling when he overtakes the car? So the equation we can use, so out of the v squared should be equal to u squared plus 2as. We don't know the s, so we are not going to use this one. So our s is equal to ut plus half at squared. This one does not have the final velocity, so we are going to use v is equal to u plus our at. So our v is equal to u plus our at, like that. So our velocity should be equal to initial velocity of the police is started at rest, so it's 0, plus our acceleration is 3.6 by our time is 19.44 seconds. So we are going to find that our velocity shall be equal to, we have a 3.6 times a 19.44. This is going to give us a value equivalent to a 69.984 seconds, meters per second. So this was meters per second squared. So we are going to have our velocity of the police officer at that instant is equal to 69.984 meters per second. Now with that considered, the second part of the problem says draw the curves of x versus t for both the motorcycle and the car at the moment the car passes the stationary police officer. So the motorist is the motorcycle is for the police officer. So we are going to say we have a x against time, meaning to say the displacement against time. So x is there, the the time is here. So the police, the car, which is the motorist, so the motorist was traveling at 31. It was constant, meaning to say the distance was covered uniformly, meaning to say it will be a straight line like that. So this is how he was covering the distance. So the distance was covered uniformly like that. However, for the motorist, however, for the motorcycle police officer, since he was accelerating, it means to say he started at 0, at the instant 0, then he traveled like that. Then he began to increase his speed, like something like that. So it will be a cave like that. Now the question is, what you might be wondering to say, why is it bending? So it has to bend in the sense that firstly, the equation of the police officer, if you remember correctly, it was simplified to S should be equal to, we had 1.8 times our t minus 2.5 squared. Now this equation that is having a square, so S is equal to 1.8, just writing it properly, t minus 2.5 squared. This equation is an equation of a parabola, meaning to say it's a curve like that. So it means to say, as the speed was increasing for the police officer, he began more like to curve in terms of the distance. So this is telling you to say, for a small unit of time, he covered more distance, as you can see. But as you can see, he covered more distance, so that's why it's curving. As you can see, if here, let's say we have 100 here, then let's say here we had something like let's say 60. It means to say he covered, let's say here from here to here, he covered in 2 minutes, he covered a distance of 40 meters, which is the difference, 100 minus 60, which will give you a 40 meters like that. So this tells you to say he covered, just in 2 minutes, he covered 40 meters. But for this other one, when you see, let's say the time, let's say from here up to here, it's 6 seconds. So for this other one, he covered in 6 seconds. That's the distance he covered in 40 meters. It means to say the police officer is moving faster than the motorist. Now this is true because for you to catch someone, you need to be moving faster than they are moving. It's a very simple logic. So that is how we answer and graph that problem. So removing these were just for illustrations. So the curve looks like something like that. So this is how we graph that one. Let's look at our next problem. Let's say for our B part, it says that suppose for reasons of safety, the police officer does not exceed a maximum speed of 45 meters per second. How long will it take him to overtake the car, and how far will he have traveled? So for this one, we have to isolate it. Firstly, we need to know how long it took him to reach this maximum speed. So what we are going to do is, let's find how long he traveled. So we are how much time it took for him to travel this to reach this speed. So we are going to use our V should be equal to U plus 80. We want to find the time it will take so to reach the maximum speed of this. So we are going to say 45 meters per second should be equal to, it still started at rest, so 0 plus our acceleration is still traveling, is started with the acceleration of 3.6 meters per second times our time. So the time which we do not know, so I can just write t like that. Then what we are going to get is, so ignoring the negative, so we have a 4.545 meters per second should be equal to 3.6 meters per second squared. Then we have t, we divide 3.6 meters per second squared, 3.6 meters per second squared. Then what we are going to get is that our t should be equal to, we are going to have our 45 divided by 3.6, which is going to give us a 12.5 seconds, like that. So if it takes 12.5 seconds to travel, if it takes 12.5 seconds to reach this speed, let us now find, so the problem to this is, after finding the time, you have to find the distance he will move. So to find the distance, we are going to say our s should be equal to ut, then we have plus our half at squared. So now we know, now we want the initial is starting at rest, so we are going to have our s is equal to 0 already. So 0 times our time, then we have plus our half. Our acceleration is equal to 3.6 times the time taken is 12.5 seconds. We square this, so we are going to have our s is equal to half times 3.6. This will give us 1.8 times our 12.5 squared. This will give us a 156.25. when we multiply by 1.8, this will give us a value of s should be equal to 281.25 meters, like that. So this is the distance that he will travel. Now the distance that he has traveled is 281.25. now we are going to also find the distance traveled by the motorist. So the police officer has traveled this distance. Let's also find the distance that the motorist has traveled. So if the police officer has traveled for 12.5 seconds, that means to say for the motorist, he will have to travel, in terms of time, he will have to travel the time taken by the police officer plus the 2.5 seconds, because already, remember, the motorist traveled for 2.5 seconds before the police officer started to move. So if the police officer has moved for a time of 12.5 seconds, it means to say the motorist has to add the 2.5 that they were moving. So we are going to add the 2.5 by plus 12. This will give us a value of 15. So we have a 15 seconds, like that. So our motorist will have to travel for 15 seconds. So we are going to have our s using this time to calculate. So our s is equal to ut plus our half at squared. So we are going to have, for the motorist, we have our s should be equal to our initial, we were told it's 31, our time taken is 15, then we have plus half. So the speed is constant, meaning to say the acceleration is 0. We have our t squared, or we can even put the value, but it doesn't matter because we have a 0 there. Then we have this. So what we are going to get is, this whole thing is 0. 0 times this is 0. So we have our 31 times our 15. This will give us a value of 465 meters, like our distance. So now, so this is for the motorist. So remember, the police travels a distance, we have calculated 281.25 meters. The motorist travels 465 meters. So now, at that point, when these travel that distance, both of them, this one is traveling at 45 meters per second, this other one is traveling at 31 meters per second. Now, how do we associate the problem? So this is what will go on. So as the motorist is moving forward like that, even the police is moving. Now, due to the fact that the police is moving with a higher speed, it means to say, so what you can think of is the fact that, let's say if you are walking, if one person is walking one step, the other person is walking two steps, like that. This is how you can think of speed when they are going in the same direction. This one is 45, meaning to say they are more like, if it's a person, they are stepping more steps in comparison to the other. So this is what is going on. So when this steps once, this one can step 2 times because the speed is greater. So this is what happens. So we are going to say 2 steps like that. This one, 2 steps, 1, 2 steps, 1, 2 steps, like that. So for each and every, until it catches the motorist, like that. So this is the same approach that we are going to be using. We are going to use, so you can think of the steps like, if let's say this one is taking 10 steps, then this one is taking 15 steps. When you subtract the number of steps, it will be 15 minus 10, it will be equal to a 5. That means to say 5 steps, this other person is moving 5 steps forward more in comparison to the other. So same with relative velocity. So according to relative velocity, it will be such that we are going to be having this person traveling more as compared to this other person. So according to relative velocity, if they are going in the same direction, it means to say you subtract. So we are going to say our 45 meters per second. So relative velocity, so you can write it in full. Relative velocity should be equal to, we have a 45 meters per second minus 31 meters per second. That means to say, since this is constant, we are going to have 45 minus 31. This will give us a 14 meters per second. So this is our relative velocity, meaning to say the police is moving 14 meters per second faster than this one, meaning to say that's the amount of speed that they are taking. So now, to use this relative velocity, we also need to subtract their separating distance. So we are going to find the separating distance. It will be equal to, so separating distance, so the separating distance shall be equal to, we have a 465 minus a 281.25. So the separating distance will be equal to, so we have a 465 minus a 281.25. So the value will be equivalent to a 183.75, like that. Then when you do that, use your equation, which is our S should be equal to ut plus our half a t squared. Since we know this, we know, or we want the time. Now remember, both of them are constant. One is 45, one is 31. So meaning to say the acceleration is 0. So none of them is more like increasing. So we are going to say our S, so the separating distance is what you put here, which will be your 183.75, should be equal to our initial velocity, will be equivalent to, so the initial velocity is equivalent to a, so you use the relative velocity, which will be our 14 meters per second. Then we have times our time. Then we have plus half. Their speed is constant, meaning to say acceleration is 0, t squared, like that. So we have 183.75 should be equal to, we have a 14 t, like that. We divide over our 14. We divide over our 14. It means to say t should be equal to, so divide by 14, this value will be equal to 13.125, like that. So these are the number of seconds it will take. So firstly, to reach a speed of 45 meters per second, we said that the police will take 12.5 seconds. Now to catch up, they will have to travel for another 31.25. So to calculate the time taken for the police officer to catch the motorist, we can say time taken should be equal to 12.5 seconds plus our 13.125 seconds, which will be equal to, we have plus our 12.5. This will give us a value of a 25 13.625 seconds. So this is our time taken. So the time taken is equivalent to 25.625 seconds, like that. So when we do that, that means to say we have calculated. Then the other part is saying that how long will it take him to overtake the car, and how far will he have traveled. So to calculate how far he will have traveled, we are going to say, so firstly we calculated how far he traveled to be equal to, for when it was 2.5 seconds, it took 281.25 meters. So we just need to now calculate the time he will take for this other time, which is our 13.2125. So we are going to say the distance he will travel will be equal to ut, like that. Then we have plus our half at squared. Now we want to calculate how much he traveled in the last 13.125 seconds. So to calculate this, we are going to say our s, remember he was traveling at a constant speed of 45 meters per second, times our time, it's 13.125. Then we have plus our half. Our acceleration, since he was traveling at constant speed, for that we are going to put a 0 by our time squared, like that. So our time is equivalent to a 13.125. So this will give us a value of s should be equal to, we are going to have a 45 times 13.125. This will give us a value that is equivalent to, so this is a 0, 45 by 13 point, this will give us a 590.625. So now to calculate the total distance, we are going to say the distance traveled for 12.5 plus the distance traveled for the last 13.125. So this will give us a value that is equivalent to, so we have 281.25 plus our 590.625, like that. So this will give us a value that is equivalent to, plus our 281.25, this will give us a value that is equivalent to 871.875 meters. So that is how you go about that question. Thank you very much for watching. Hope you would like, subscribe and share for more. Don't forget to like so that my video can reach a broader audience. Comment if there is anything that you want. See you in the next tutorial.